When a system is taken from state A to state B, along the path ACB, 84 kilojoule of heat flows into the system and the system does 32 kilojoule of work. That is, when a system is taken from state A to state B along the path ACB, 84 kilojoule of heat is flowing into the system and the system does 32 kilojoule of work. That is, Q of ACB is equal to 84 kilojoule and W of ACB is equal to 32 kilojoule of work. Now, we have to find how much of the heat that flows into the system along the path ADB if the work done is 10.5 kilojoule. That is, the work done on the path ADB is given, which is 10.5 kilojoule, and we have to find the heat transfer along the path ADB. That is, we have to find Q of ADB. We have to find the value of Q of ADB, and we have the value of WADB, which is equal to 10.5 kilojoule. Okay. When the system is written from B to A along the curved path, that is, when the system returns from B to A along the curved path, work done on the system is 21 kilojoule. That is, in this case, the work is done on the system. Therefore, W of BA will be equal to 21 kilojoule, and which has a negative sign. That is, work is done on the system. So, we are using a negative sign in this case. We have to find, does the system absorb or liberate heat and how much of the heat is absorbed or liberated. We have to find whether the system absorbs or liberate heat, and if it does absorb or liberate, we have to find the amount of heat which is being absorbed or liberated by the system. And if UA is equal to 0 and UD is equal to 42 kilojoule, find the heat absorbed in the path AT in the process AD and DB. We have to find the amount of heat absorbed in this process A and D and DB. Okay, this is the question we have given. We have Q of ACB is equal to 84 kilojoule and work done in the same path ACB is equal to 32 kilojoule. Okay, and we have to find how much will be the heat that flows into the system. How much of the heat that flows into the system along the path ADB. We have to find Q of ADB. We have to find this value. And first, from first law of thermodynamics, we have Q of ADB is equal to change in internal energy UB minus UA plus WADB. And we have the value of work done in this process, that is WADB is given, which is 10.5 kilojoule. Okay, but the value of heat transfer and the change in internal energy are unknown. So first we have to find the value of UB minus UA. We can find the value of UB minus UA from these two values, that is the heat transfer along the path ACB and the work done by the same path is 32 kilojoule, and this both the values are given. So by using these two values, you can find the value of UB minus UA. That is, Q of ACB is equal to UB minus UA plus WACB according to first law of thermodynamics. And from this, UB minus UA will be equal to Q of ACB minus WACB, which is equal to 84 minus 32 kilojoule. Okay, and UB minus UA will be equal to 52 kilojoule, and we have find out the value of change in internal energy for the process B2A. Next, by substituting this value in this equation, you can find the value of heat transfer along the path ADB. Okay, and Q of ADB will be equal to 52 plus work done by the process ADB. Work done by the process ADB is given as 10.5 kilojoule, and substituting this we will be getting the value of Q of ADB, which is equal to 62.5 kilojoule. Okay, and we have solved for the subdivision A. And for the subdivision B, when the system is written from B to A, that is, when the system is written from B to A along the curved path, B to A along the curved path, work done on the system is 21 kilojoule. That is, in this case, the work done is on the system. Therefore, for subdivision B, we have work done for the process B to A is equal to minus 21 kilojoule. We have this value, and we have to find whether the heat is being absorbed or liberated by this process. So we have to find Q of BA, and from first law of thermodynamics we will be having UA minus UB plus WBA. We have the value of UB minus UA, that is change in internal energy for the path A to B, and we can use the same value for this equation too, that is UB minus UA is equal to 52 kilojoule, and we can write UA minus UB as minus 52 kilojoule. By substituting, we will be getting, that is Q of BA will be equal to minus 52 kilojoule minus 21 kilojoule, and Q of BA is equal to minus 73 kilojoule. And from this we can say that system liberates 73 kilojoule of heat, that is system liberate 73 kilojoule of heat. Okay, and subdivision C, if UA is equal to 0 and UD is equal to 42 kilojoule, find the heat absorbed in the process AD and DB. We have to find Q of AD and Q of DB along this path if UA is equal to 0 and UD is equal to 42 kilojoule. Okay, subdivision C, we have UA is equal to 0 and UD is equal to 42 kilojoule. We have to find Q of AD and Q of DB. We have to find this both values. Let's find the heat which is given to the system along the path AD, that is Q of AD, which is equal to UD minus UA plus WAD. Okay, here we have two unknowns, that is the heat, we should find the heat transfer along this path AD, and WAD is also unknown, that is we don't have the value of WAD, but we can Find the value of WAD, that is work done along the path WAD, by equating the work done along the path ADB. That is, we have the value for, we have work done along the path ADB, which is equal to 10.5 kilojoule. And while equating, we can get the value of WAD, which is nothing but, which is equal to WAD plus WDB. This WDB will tends to 0 since this is a constant volume process, and for a constant volume process, the work done integral of PDV work will be equal to 0. Therefore, this equation will have a value of 0. That is, the work done along this path dB will be equal to 0. Therefore, we can conclude WADB will be equal to WAD, which is equal to 10.5 kilojoule. Now we can substitute the value of work done on the path AD in this equation, and you can find the value of QAD. Okay, the value of QAD, the heat transfer along the path AD, will be equal to UD is equal to 42 minus 0 plus 10.5 kilojoule, and the heat transfer along the path AD will be equal to 52.5 kilojoule, and we have find out the value of Q of AD, which is nothing but 52.5 kilojoule. Now we have to find the value of Q of dB. In the same way as we have done to calculate the value of work done, you can also use the path Q of ADB. That is, we have the value of work done along the path this ADB to find the value of QDB. Okay, which is equal to 62.5 kilojoule. We have this value, and Q of ADB is equal to Q of AD plus Q of dB. We have the value of QAD and QAD. That is, we have the value of QADB, which is 62.5 kilojoule, and QAD, which is 52.5 kilojoule. And for 3 equation which involving only one unknown, and you can find the value of Q of dB, which is equal to 62.5 minus 52.5 kilojoule, and Q of dB is equal to 10 kilojoule.